Hello and welcome to this lecture. In this lecture, we will go into Apache Kafka and the theory about it. This is a super interesting topic. As Apache Kafka, you will work with real-time streaming data and you will work with events. It's a little bit different thinking from what you might be used to before. So here in the keynote, we have working with real-time data with Apache Kafka, a distributed event streaming platform. What does this mean? What is event? What is streaming? We have talked about already, but what is event? And let's dive into this. So let's start with the beginning. So we have traditional databases, for example, SQL databases, and they represent physical and logical entities. For example, here you have databases and customer tables. These exist in the real world, right? You have a customer ID, first name, last name, and email. So this is the state of this customer table. And whenever it changes, the state changes, right? And you might have orders table, products table, and payment table. These are traditional databases. Moving on, we'll go into events and see what that is. Real-time events. Let's go into an example. Let's do some online shopping now. So we create a customer. Customer created. This is an event. And then customer logs in. This is another event. Customer updated. We update our profile. This is another event. We add a product. This is an event. We add another product to our shopping cart. This is another event. We place the order. And then we pay. The payment is processed. This is another event as well. Customer logging out. This is another event. Finally, the order is shipped. And this is another event as well. And as you can see, there's a lot of events. And these events are things happening in your business. It happens at a time point. And if you put this into the database, this will be quite hard to scale and keep track of. In traditional database, traditional systems, mostly they might have everything of this inside of using one or a few databases, and everything is very tightly coupled. This is called a monolithic system, and it's hard for developers to keep in their head because it's too complicated. So you divide it into several microservices. That is one thing that Kafka will help us with. Note that these are the events, right? We have a lot of events. An event is basically a record of something that happened. It's also called message or record or message. It's something that happened. And the characteristics of an event is basically it happened at some point in time. And the state has changed. For example, the profile has been updated. This is a state changed. An order has been placed. The state has changed, right? It's immutable. So an event, it has happened. And then it has happened. You cannot change the event. You can append new events. It can be stored and replayed at a later time. For example, you store it somewhere, and then you have another application that reads this one by one in a certain order. Then you can do some processing of it. The structure of an event contains an event type. For example, order placed is an event type. It has a timestamp. And an entity ID, for example, customer ID is an entity ID. Metadata, so data about this event. So some description of it. So these are quite normal structure of an event. So let's look at an event. So this is an example of an event in JSON structure. So you have event type, timestamp, customer ID, order ID, and items, right? So let's look at this one. Order placed. It's the event type. And then we have customer ID. This can be used to track what this customer has done throughout his or her journey through your system. For example, you can see here the items it has placed, but you can use this to go through every event that this customer has had. So how to store these events? This is where Kafka comes into place. These events are stored in something called Kafka topics. So what are topics? This is Kafka topic, and you have here an event coming in, and it's basically an ordered sequence of events in a topic. So you could call a topic, for example, orders topic, and you could have several orders there. And an analogy to a topic is a folder in your file system, and events are the files. Kafka topic is a logical grouping of events stored in an ordered sequence. That is very important. So it's ordered, right? So then you're reading it in order as well. Moving on, we can have several Kafka topics. A Kafka broker is a server that stores and manages multiple Kafka topics. It could be some cloud, and it could be that you have it could be some other. It's so on-prem or local or cloud, but it's a server, so it's basically a computer. Here you have a topic, another topic, and another topic. So you have several topics in a broker. There's no hard limit to how many events can exist in a topic. Note that in a topic we have several events and several topics in a broker. That is how the relation between these are. The Kafka broker could be run on the cloud or locally with or without a Docker container. We will show you locally with the Docker container using Docker Compose. So in the setup, you will see that. We have a Kafka cluster. It contains multiple brokers. The streaming platform is very scalable. So you can divide it into several servers, right? So this is a cluster. So several computers working together. So this is a Kafka cluster. And inside of the Kafka cluster, we have broker 1, broker 2, and broker N. So this is very scalable. Kafka has systems to make this work neatly so that it's easy to scale when needed. So you have now seen the theory behind Kafka and behind the events and topics, so how they are working together. And this, I hope with this you have gotten some introduction on what Kafka is. In the next lecture, we will go more into the Kafka producer and consumer for creating and consuming events. Thank you for watching this video and see you in the next one. Bye.